A very happy morning to all the participants and a warm welcome to our resource person, Mr. Sunil Kulkarni. It is indeed my privilege to introduce our resource person, Mr. Sunil Kulkarni, to all the participants. Mr. Sunil Kulkarni is a technical expert from Robert Bosch Engineering and Business Solutions. He is a talented technical person with approximately 20 years of overall software industry experience in architecture, design, and development of embedded software products for automotive systems. His areas of expertise are requirement analysis and technical inputs for RFI and RFQ, and architectural definition, high level design, technical review of low level design. He also has experience in achieving successful SOPs for car infotainment system. He's proficient in developing generic software subsystems that can be reused for various programs. He has expertise in architecture, design, development of middleware applications for speech over the air software, update building blocks using C, C++ on embedded platforms. He's also involved in drive innovation, future technology, and roadmap topics, prototyping, proof of concept in Robert Bosch. We are indeed privileged to have you with us here today, sir. Over to you.
Good morning to all. So hope I'm audible, and then I'll probably share my screen. You can actually confirm if you would actually see the screen.
Yes, sir, you're audible. The shared screen is on.
Sure, thank you. Thanks for this opportunity to be in my team, and then looking forward for an interactive session. I think I will probably go through how artificial intelligence and machine learning has actually brought in some disruptive trends, and then how it's actually transforming or what are the developments related to it in the automotive industry. So I think an introduction was given about me. I'll probably not go into the same thing. So I work as an expert at Robert Bosch India office, and then I'm actually a certified software architecture professional from my security, and then also functional safety certified professional. And then I'm actually basically an engineering graduate in electronics and communication engineering, which I completed from CA College.
So sorry to interrupt. There's some glitches in the voice.
Is it clear now?
Yeah, better, sir. It's better now.
Okay. 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 So I completed my engineering from PA College, and that's in Gulbarga, where I actually came from in Karnataka. And then hobbies typically, I think, sports, music, and then a bit of yoga and gardening as well. So thanks for this opportunity. And then this is how the agenda would look like for the discussion. Please feel free to kind of interrupt in between in case of any questions, or you could post those questions on the chat window, and then we could actually take that up. Then we'll probably look at a bit of history and evolution of how the automotive industry has actually evolved, right from the radios or even the first car till where we currently stand, of how we are actually looking at maybe some kind of a driverless or a self-driving car. And in this particular area, what are the emerging trends in the automotive industry, and then how AI and ML has actually influenced these particular trends. And then we'll also look at some of the applications, or maybe the overall what are the possible use cases or the areas in which AI and ML could actually be applied in the automotive industry. A quick look at what could be the potential challenges, and then we open the floor for some question and answer sessions. Okay, so if you look at the history, right, I've just taken from 1990. I think the first car actually came up in 1986. That was from Benz, and then we actually had the car being evolved But fundamentally, why I took from 1980 is this is the time when more of this built-in GPS satellites came into picture, the navigation system came into picture, more of how a car could actually be used slowly as some kind of information and an entertainment device. So 1990 was when we actually had the built-in GPS, satellite, and the navigation systems. And then eventually in the 5 6 years time frame, there was this connected cars that actually came. Primarily, this was mainly from the safety and emergency services perspective, wherein which there was this connectivity to OnStar, which is actually an emergency service provider in the United States. In case of some emergency or some kind of accidents or additional information or establishing call to an emergency contact, all these things would be possible by the simple process of this particular on-star button that we see here. And then this also brought in a lot of safety features, more like airbags came into picture in case of any accidents where they could actually be deployed. It typically started from the airbags right in the front uh, part of the car, for the driver and the passenger. We also had some basic object detection sensors that actually came in, not full-fledged that we currently see with radar or lidars that we actually have. Its display started to evolve slowly, and then we typically had adaptive cruise control. So that's typically the case from 1990 to 2000, especially with the smartphone industry also slowly disrupting and then bringing in the Bluetooth and the smartphone connectivity coming in. Now, when we actually looked at 2000 to 2010, the decade from 2000 to 2010, we actually had the main smartphone disruption, which meant that people started expecting having touchscreen in the infotainment display as well. They wanted LED headlights. They wanted Bluetooth functionality to be available. They wanted the entire smartphone to be integrated. And with all these particular distractions coming into the system, right? So the speech and voice actually acted as using the system without really pressing on the touch screens. So that started slowly evolving during this particular phase. Although it was actually coming in as some kind of a fancy feature at that particular point in stage. So the blind spot detection and then even the automatic parking. So these things came up maybe at the end of the decade, somewhere around 2007 to 2010. And that's when a lot of things started coming in. Purely the consumer industry started disrupting the automotive industry. A lot of people tech savvy and then had very good experience using the mobile phone, and then they started feeling more comfortable of using all of those fancy features in the car. So that's when a lot of things came in. The first license for autonomous car came in 2012. So that's when the first autonomous driving license actually came in, mainly from the driver assistance, and then automated driving, mainly bringing in more like lane assistance, collision avoidance, automated braking. So all of these things came into picture, while the user could actually go ahead and then unlock his car with his smartphone. There's still a big question mark of how the safety and security aspect is actually addressed over here, because this brings in a bit of possible malfunction, especially allowing users access to their smartphone. So these are something that are being evolved going forward as some kind of challenges. And then with the Alexa and Google Homes coming to every home, right? So all of these particular things, the Apple CarPlay, Android Auto, Alexa, all of these things are actually acting as digital assistant, wherein which they will typically sit within an autonomous car, which is no driver, and then they would actually help out to the user as if they are their assistant to help them out. So that's typically how the industry has actually evolved till now. So where we are currently operating on. So Speaking about the autonomous vehicles that we actually spoke about, and then this is more of a trend, how the industry is going to evolve. I mean, like up till 2030, 2035. So I'll be touching upon in my future slides about what exactly we mean by partly automated, highly automated, what exactly these systems are. So these are typically different levels of autonomous cars, right from level 0 to level.
So just a second, sorry to interrupt you. Your voice is having some glitches. It's coming perfectly at one point, and probably when you're moving around, it's having some glitches. So
Mhm.
yeah, at this point it's perfect. At some
Okay.
point,
So is it more like dragging? The voice is dragging or something like that, or
yeah,
getting cut?
it's kind of dragging. Yeah, I think when you're
Okay.
still, you're able to hear perfectly. I mean, at this point, I'm able to hear you perfectly, but at some point, it just like delay or a glitch or drag, something like that is happening.
Okay. Just let me know. I'll probably try to maybe form short sentences because I couldn't really correlate what could be the issue. Maybe just let me know, and then I probably see if I need to really switch on to another network or something. That's all.
Yes, sir. But I'll see for another 5 minutes. If the issue persists, I'll just keep you informed.
Perfect. Okay, so what we actually see is how the autonomous vehicle technology is actually going to evolve, typically up to 2030, 2035. What we actually see here is what would be the aspects related to the legal protection for each of these categories. For example, if you actually look at the legal protection, right, in the part of the automated systems, we actually have a scoring system with to enable preventive driving. So we actually have a score, and then the user will be notified with that particular score. And then as and when the score really comes down, right? So that's the indication, and with the parameters user is informed that he needs to improve on certain aspects, more of a driver behavior, we can kind of perceive it in that way. When we actually go further with highly automated, then there will typically be legal protection for any car rental or car to book. Typically, the Ubers, Olas actually come into picture. But when it comes to fully automated system, right, we will typically have legal protection based on mobile devices. So that's typically the projection in which the trend is going on. 2030, this particular thing would be extended to all devices, and same thing would typically continue further when we actually have protection for all the devices. Now, from the technology per se, what we actually look at, so the partly automated is actually first generation automation, mainly what we touched upon in the previous slide, right? Mainly more of lane detection, collision avoidance, automated braking, so automatic cruise control. So these kind of automation and controls are actually there in partly automated system. But when we actually get to the highly automated system, right, this is when the system would typically go ahead and have a lot of aspects automated, but they would still need a driver to be present in case of any special scenarios, and then the driver needs to kind of interrupt or operate out of the vehicle. Uh, Fully automated is when there will actually be complete automation with driverless cars, typically for a fixed distance, not typically ideally for long drive or so. So that will be accommodated in this. And finally, when we actually speak about the autonomous driving, right? That's when we would actually have complete automated systems, including traffic junctions, traffic signals, connectivity to the external world. All of these things would come in, and we would typically eventually get into some kind of a fully automated traffic management system. Uh, this would require a lot of infrastructure needs and to individual infrastructure needs. Typically, when we look at for partly automated, it's typically targeted for high networks, and eventually the scale or the magnitude kind of expands, and then we would typically look at by 2035 it would yes.
Sir, sorry to interrupt. Sir, can you switch off the video and try once because still the glitches are there.
Okay.
Might be due to the, can you switch off your video and present? Let us see the voice break.
Is it fine now?
No, sir. Is it? I think some problem with your headset. Can you use the speaker or the normal one?
Okay, let me try that.
So you're not audible.
Yeah, am I audible now?
Still some glitches are there. Sir, can you try connecting to some other network if possible?
Yes, I already shifted the network.
Okay.
Is it fine now, or you still
Now
see
it is fine, sir.
some issues?
Now it is fine. Now it is
Oh,
fine, sir.
okay, perfect.
Yes, thank
Perfect.
you.
Sorry for that particular glitch. I think
It's okay, sir.
present
I think
screen.
let us not switch on the video, sir. Only presentation you can start, I think.
My slides are visible.
Yes, sir.
Okay, perfect. So I think we were discussing about the infrastructure. I think when we look at the evolution of the infrastructure, right, it typically starts from highway networks where it is currently there. And we can use maybe the current existing features of automated driving like lane assistance and other things. Eventually, it is going to expand maybe from the region or national network mega cities, and then eventually the plan is that it would actually expand to the global interconnected mega cities. And then the standards typically are also going to evolve. So we are now starting with the standards typically from the apps and the mobility industries. But that will actually evolve because we will actually have a lot of cameras, sensors, image processing, and then we will also have the automation standards that will actually evolve and come up. And eventually we are looking at some kind of fully automated vehicle networks or standards. That's how the industry is going to evolve from the maturity perspective. Uh, a quick look at the numbers. I think 2022 to 2025, it actually seems there isn't anything on the fully autonomous vehicles market. But 2030 and then 2035, if you look at the market, by 2035, it's expected that the autonomous vehicle market is typically going to evolve somewhere close to $60 billion. And that's typically constituting close to 17% of the total automotive market that we speak about. So this is one major thing that is actually going ahead and evolving. So now with autonomous driving, more of driverless or self-driving cars, how we want to put it, we typically have a lot of trends that actually come in the automotive industry. So we'll probably have a quick look at those particular trends, unless we have some specific questions related to this. Okay, when we look at the trends, this is actually a consolidation of a lot of different research and analysis that we have actually done. So we actually see pace as one of the trends. Some people say easy as one of the trends, EAS, five. So I think the primary thing are actually these five parts. So I would probably term that as space to a meaningful word here. So we typically have shared mobility, uh, and then we would actually have personalization as the second major trend, automated as the third major trend. Typically, this is the clear one with autonomous vehicles. Connected, the vehicle would actually be connected to all different possible values. And then we actually have the electrification that actually comes in more towards the greener environment. So these typically are the top five trends that we would actually look at. So what do we mean by shared? I think this is very clear. Most of us use this day in, day out. We actually have the Ubers, Olas coming in. We actually have the quick rides, and then we have the Ulus. All of these things are coming in. And these are typically dedicated based on the distance. So if you see at 0 to 5 miles or so, right? Then typically we would go in with some kind of a scooter kind of shared mobility. If you look at medium distance, this is a standard, very common already in practice system of renting out a car. And if you look at long distance, then we typically have maybe more of a car sharing, or we would actually have car rentals, Zoom cars, car to go, these kind of scenarios uh, coming in. So this is what we actually mean by shared mobility, and this is actually disrupting the trend because traditionally people are actually used to own the cars and then having their own cars, and this brings in a lot of aspects or challenges with the own cars and with how shared mobility is disrupting. I mean, on a bit of numbers, the shared mobility is eventually going to uh, come in 2027. It's actually going to go ahead and then evolve going forward. So 2025 is typically where it is actually going to actually meet, and then the current scenario is it's actually having a pretty much high ride of this. So the cost that is associated with shared mobility is pretty high now. If you see, it's something around 30,000 US dollars. And eventually, when we actually look at the cost of shared mobility, is eventually going to come down. And maybe by 2027, it typically overtakes the car ownership. The cost associated with owning a car would probably be much higher than opting for the shared mobility setup. So that's typically the reason why this is one of the disrupting trends. So what brings in, or what advantage this brings in, is the evolution of dockless systems. What that means is we can typically park the vehicle anywhere. Let's take an example. We probably take a vehicle, a shared vehicle. Maybe you know, right? That's a classic example. Or we actually think about Ola or Uber, or even a rented car. The current challenge that we actually have is we will need to drop these particular vehicles at the respective dealer or the rental outlet. Now, dockless systems means we can actually park it anywhere. So we go to a supermarket, there is a nearby place where we actually park these particular vehicles. So that brings in more convenience to the user as such. So the next one is distance-based on-demand service availability. So what we already touched upon, based on the distance, we actually have the service available on demand. And then the ease of use with the technology trends emerging, and then lot of sensors, GPS, and then even the UPIs coming into picture. So to locate a vehicle, to access it, and then even payment of these particular vehicles actually becomes much more easier. More so in the current COVID scenario, wherein which we would like to have contactless delivery and then contactless payments. Now, the other one is the car maintenance. Typically, if you look at the insurance or the fuel costs or even the depreciation of the car running over a period of time, the car maintenance is actually higher. Even the trend kind of indicates that. Then we would actually have the challenge of driving hazards, how we actually drive, the health issues, the road conditions, all of these particular things typically be reduced because we wouldn't be driving typically be some kind of a shared vehicle or there would actually be some kind of rental vehicle with the driver that would actually come in. And it will be very easy because we will, going forward, we will actually have even more younger and tech-savvy users where they are very comfortable using these particular systems and operating these systems. So that's the first disruptive trend that we actually have. So moving on, the second disruptive trend is personalization. I think we have seen this to a certain extent. I'll probably take the classic example of all of us buying something on, say, Amazon, Flipkart, or so, right? Over a period of time, what the system does is it learns what are the type of purchases that we have done, or even what are the recent searches we have done. And then it typically goes ahead and shows on the top that maybe we continue searching from this item, or it lists out what items we searched, or we could even put that into a wish list, and then later it shows if there is any change in the price. So that's typically personalization to every individual's need. That's this personalization in a nutshell. So now what in the automotive industry comes in is, one is the smartphone connectivity to the car. This brings in a huge personalization part. Uh, and then we also have a lot of efficient algorithms. I think AI and ML will come into picture during that particular phase. How we could go ahead and have our preferences. Let's take an example of shared mobility, right? I probably go in Ola or Uber. Now, what is my seating position? What is my preferences? What exactly is the AC temperature that I would actually want? What kind of music that I would actually like, or what kind of drivers or traffics that I actually prefer. Do I prefer going on highways? Do I prefer going into the downtown or within the city limits, or do I go with some kind of a greener belt kind of a travel, right? All of these preferences can be stored into our mobile devices every time we get into a particular car, and then they would typically be plugged into any new car that we actually jump in, and then that will actually go ahead and customize it to every individual's needs. So that's typical personalization based on the individual preferences. Some critical scenarios is we can actually go ahead look at the driver behavior and then have a driving score. For example, if somebody is not comfortable with the speed limits, then you actually tell no, we would like to go into a vehicle where the driver maintains a particular speed limit or goes in with certain specific driving behavior as such. Very, very interesting scenario is can we go ahead, say I have a own car, and then I actually have a specific driving score. I ensure that I go ahead and drive, follow the rules, regulations properly, and then all of these data can actually be stored, and then it could also go ahead and connect with the insurance companies, and then I could typically go ahead and get a discount. Okay, your driving score is very good, very similar to the credit score, right? And then we'll probably give you some kind of a 5% or a 10% discount on the insurance premium. On the contrary, if the driver is actually doing the rash driving, then there would actually be the additional charges on the insurance premium. So that's again personalization to individual driving behavior as such. Right? And then the next category would typically be on the ease of driving per se. System could actually go in and then have all the information stored, what the user's work routine looks like, what's the timing that the user uses, or what are the typical dining or the lunch restaurants that the user goes in, whether there are parking lots nearby to that particular place, which one is close, whether the user prefers a little far and then walking down. All of these particular information can constantly be captured, apply as the customer to the user needs. So we can actually think about some kind of a knowledge model or some kind of a database which captures all the user preferences and choices and then accordingly decides what is the best preference for the user. Okay, quick check if I'm audible. Hello.
Sir.
Am I audible and still in line?
Yes, sir. Yes, sir. You are audible.
Okay.
Yes, I mean, a little bit of glitches is there, but it's reduced, but it's not completely zero. Uh, it's better than with the video.
Definitely, perfect. That should be fine. Thank you. Okay. Now, one of the big challenges here, right, is when we speak about all of these data and then user preferences and storing of user data, the question about data privacy comes into the picture. Maybe a lot of things that everyone knows is actually concerned, right? How much data is actually stored, whether it's our personal data. So there are these regulated guidelines that are actually coming in, which is called as GDPR, Global Data Privacy Regulations. And adherence to that particular guidelines will be one of the important part when we speak about personalization. So that is one area, challenging area. So eventually, to put it in a nutshell, we convert the car into our own personalized area, be it a shared car or our own car. It already knows what exactly is our preferences. So effectively, we try to replicate our preferences like a home and office into the car. Okay. So the next trend is typically the automated driving. I think we touched upon this in our initial one with autonomous driving and self-driving cars. So this is how the system evolves. What we see here, the partly automated case, this is where we are currently, wherein which we actually have a system that can actually do in detection, collision detection, and then we would typically have the driver would actually need to ensure that he actually is available and then overtakes certain special conditions that would actually come in. So that's partly automated. Zero is driver only, the traditional system where nothing is actually there. Driver is the full owner or full control of it. Assisted driving is way the cases where majority of the things driver takes care, like lane changes and other parts. Maybe some aspect of automated braking in case of certain emergency scenarios. Those kind of scenarios is typically in assisted driving. Maybe some kind of acceleration, those kind of scenarios. Partly automated, we already touched upon. The next thing is the level 3 autonomous driving systems, wherein which the driver doesn't need to constantly monitor the system. They can actually be present there, but his action will be needed only in case of certain special or specific scenarios wherein which he needs to actually take over. Example would be maybe it's running on an adaptive cruise control, and then it estimates that the front vehicle is also going at a particular speed. And for some reason, there is a sudden brake that the driver in the front vehicle applies. So in such cases, there probably be a notification of a warning with certain speed reduction in which the user needs to kind of take over. That's more on the maybe trying to visualize how the highly automated system looks like. And when you speak about fully automated systems, this is where we don't need the driver. Even in case of special applications, the system would typically go ahead and issue warnings for people who are actually there, and then the system can actually handle situations in certain specific areas or localities, like maybe tied to or type 3 cities. How this could be deployed based on infrastructure, there could be a need of a driver to monitor it. And that typical scenario would actually be evolved when we speak of a complete driverless, wherein which the system is fully capable of handling anything and everything, including load capacity, what would be the throughput, what would be the traffic conditions. All of these things would be handled without a driver. So the most important part is LiDAR as a sensor has actually penetrated a lot and then giving a lot of object detection and accuracy aspects here. That actually is an important part when we speak about this company autonomous. So all of this is actually possible purely because of a lot of maturity and then a lot of accuracy and technology advancements in artificial intelligence and machine learning algorithms. So this is one of the major parts which is enabling autonomous driving. So the next one, continuing on the autonomous driving part, what we speak again is a trend here. How the autonomous driving would actually pick up based on the market share and what are the number of vehicles. So what we see here is by 2035, 40, from 2030 to 40, right? This is where we typically have a lot of autonomous driving vehicles, and then these typically be available in more of regular models. First, it would start from popular models, specific models, and then we typically have the regulatory and the technical challenges addressed at a commercial scale. And then finally, we typically go ahead and have the fully autonomous vehicles that actually come in. So that's where somewhere around 2040 is where the prediction is. We typically have fully autonomous vehicles actually coming into. So what does this mean? They would actually reduce the harmful emissions because there will be a lot of regulatory norms. Vehicles actually need to follow this when these vehicles are deployed and then ready for use. They need to ensure the regulatory norms are met, so which would typically reduce the emissions. And then this is a tricky one. I mean, like some analysis say that the number of vehicles actually reduce because of shared mobility, and that's where lesser the number of vehicles, lesser the CO2 emissions, and then it actually is safer for driving. The other analysis says with more of automated and then connected cars with complete traffic management system, the speed at which the vehicles run and operate is actually much higher. That means less traffic congestion, and then that would mean there would be much more vehicles on the road. The road capacity would actually increase. So there's a little tricky debate going on the number of vehicles on the road. But fundamental point is, since these vehicles would actually contain a lot of norms, I think they would reduce the harmful emissions, and then the gases burned would actually be lesser because of automated systems. That's also one part that could actually take care of. And then what we actually have is based on the driving style. So there could be recommendations based on the driving style of whether certain usage, for example, somebody uses the infotainment system high or connects their smartphone to the infotainment unit. or somebody does a lot of accelerating or de-accelerating or more manual intervention in the cars. Now that means that it could actually result in larger battery consumption. There, we could actually notify the users and then ensure certain optimal operation to take care of less battery being consumed. So, mobile businesses, maybe COVID has actually brought this particular thing into more limelight. Whether we can sit and work in the car or on the way to office. So all of these things will be possible because we will really be driving cars. And that would mean like a car typically act as a turning space, in which we would probably be more of passengers enjoying the comfort of the vehicle. We have recent entertainment and then use that as more of a second home. And one very important part is, especially for the physical challenged people, this will actually be more of a big respite because they can just go ahead, sit into a driverless car, and then it would enable them to be much more mobile and moving around much properly. Okay, moving on. So the next one is more on the connected trend. Connected cars that we actually have. What do we mean by connected cars? Is connectivity between two vehicles, that is B2B exchange of data between vehicles. It could be a short range communication. It could be a long range communication. It could typically alert what could be the potential dangers based on the vehicle to vehicle communication, which in turn would mean like reduces accidents and then also ensures that the traffic congestion is reduced. So the second one is vehicle to infrastructure, in which the vehicle actually has connectivity to all the infrastructure, gets a lot of traffic updates, weather updates, weather advisory, and then informs the driver of what would be the conditions. Let's see the scenario that we are probably going, maybe I'll probably take the longest part, like Kashmir to Kanyakumari. In that case, what's the weather in Kashmir and then what's the weather in Kanyakumari? So those and what's the weather on the route, that could actually be informed to the driver, which would mean like the right safety measures could actually be taken. The next one is vehicle to everything. Like we could typically go ahead, connect from vehicle to home. Say while going to office, we forgot to switch off the diesel button. We could probably control that from our car and then ensure the diesel button is switched off. So we head to home, uh, other cars, infrastructure, everything. Right. So that's V2X. So then we actually have a smartphone being connected to the cars. So, I mean, a simple thing, right? We have actually parked vehicles gone for shopping, 5 minutes just when we want to go out or return back from the shopping. We typically connect to the car remotely from our smartphone, have our own settings, maybe switch on the AC, maybe pull down the windows a little. So, and then we typically go ahead and have a much more comfortable environment when we actually start driving. Right? And then we touched upon the self-driving cars. I think with a lot of ultrasonic lidar and radar sensors, with three-dimensional digital map, it gives a completely different comfort feeling to the user, along with bringing in the safety and security aspects. So the next one is electrified. I think gaining a lot of momentum, especially with a lot of infrastructure within India also coming in. So uh, typically, the trend is moving more towards hybrid vehicle, wherein which it operates on fuel and battery. But eventually, the goal is to go in with a fully electric vehicles, and then that's the prediction that by 2030. Share of the electrified vehicles could actually go from 10% to 50% in new vehicle sales. Stricter emission because we do not have fuel to emit a lot of gases out, right? And then the battery costs are actually drastically reducing. And then that means we actually have more affordable batteries within the vehicles, which means more affordable electric vehicles. Although not a scenario currently, it's still a question mark as to what different segment or class of people would actually afford electric vehicles at this point in time. But eventually, with all the costs decreasing and then infrastructure coming in, maybe of proper charging stations, this is something that is actually going to kind of hit the markets. And then another technology. Any questions on the trends so far?
So the voice seems to be breaking now and then, sir, but it's fine. No questions as far.
Okay. Okay. So then moving on, now we actually come to the core of this particular event on the AI ML, how this is actually influencing. So when we look at all of these self-driving cars, shared mobility, personalization, automated, connected cars, so that means the entire car infrastructure and then the outlook towards the car typically changes. What that means is how we could bring in intelligence and then bring in lot of learning into the systems. I think these are some numbers. I think the AI market in cars is anticipated to reach 250 billion by 2025. And then the installations with AI and ML are expected to rise by 109%. Lot of biggies like BMW, Tesla are actually increasing and investing heavily in AI and machine learning, typically to create autonomous cars or even going ahead and predicting and planning routes. A lot of computer vision enhancements coming into picture. So, and then on top of that, the recent pandemic has actually added even more faster pace for more innovations in this space. So, uh, this is one quick survey that was actually done by McKinsey, considering some 3,000 odd users. I think they actually asked the users these set of questions. Do you see AI as a major enabler for change? Do you think AI has risks? And then how would the idea of your family members using autonomous driving today make you feel? Now, these are asked to industry experts, these are actually asked to startup vendors, end users, all different kind of stakeholders that were involved in this particular survey. And then the result kind of is something that actually shows. So if we look at it in totality, right? I think 15% typically say ban. I think 38% are really unsure how it will actually shape. And then we have 47% say that they will probably be they would feel good if their family members use fully autonomous vehicles. And then this also has the information about where all the audience were there. It had urban areas covering Germany, US. It had audience under 30 years old, and then it also had a lot of people from China. So this is actually was a little surprising number for me personally. That from the China perspective, 73% are actually on the positive trend towards AI and ML. Overall, it looks somewhere around the 50-60 range mark. But when you consolidate the entire data, almost 47% would feel this would actually be a very good thing going forward for the family members. So that's typically the influence of AI and machine learning coming in. What that means is, if you look at the autonomous vehicles, the overall pipeline or how the autonomous vehicles operate changes. I think most of you would be aware the typical standard processing AI and machine learning. One is maybe the data collection part, and then how do we actually operate on that particular data, interpret that particular data, make right decisions, and once we make that particular decisions, how do we act on it? The classic pipeline of data capture, compute on the planning, and then act. So sense, plan, and act process is what it looks like. So when we speak about the data collection, the guidance systems actually come up with lots and lots of sensors for each of the different purposes. For example, ultrasonic sensors are something that we already know in parking, wherein which they actually notify and give warnings. Radar is something used for object detection, and then we actually have long range radar sensors mainly to gather traffic information and then predict what would be the way. They actually have short sensors that will probably go ahead and detect blind spots, surround view sensors, all of these particular things. You need cameras, very sophisticated cameras that could actually capture accurately within the specific time, give the input in real time, and then we actually have the GPS sensor. One interesting one is the IMU, which is inertia management sensor, which typically figures out if there is any inertia in the self-driving car, and then that would actually have some kind of adverse impact. And then, of course, the traffic light signal. So, what kind of data does this capture? So, the main goal is the system to be able to mimic the human driver, right? Whatever the human could actually see and capture the data, the system should be able to capture. It captures the information about the road infrastructure, other vehicles, what objects are there on or near the road, information about traffic, parking, transport, and even the environmental information, whether it's raining, whether it's foggy conditions, or whether I mean, like there is some kind of problem in the road, some road deviations need to be taken. All this information is actually captured as part of data collection, which means this is billions of hours of data, right? Lots and lots of data. So that brings in a lot of data analytics that actually comes in the picture here. So we'll actually have the autonomous vehicle system store all these particular data constantly. I think it maintains a collection of data over a period of time, and then also what is the driving experience, what action the user has taken in the past, and then operate on the data and take plan and what would be the appropriate decisions that needs to be done with this particular big data. And then once it actually makes a decision, how do you actually go ahead and control this particular data? How do we actually go ahead and then find the safest or the most convenient and then the most economically beneficial to the user, right? That's typically the overall control strategy. So this is where a lot of machine learning algorithms and artificial intelligence comes into picture. Uh, and the real intelligence that is visible to the user is when we actually act. So we typically have the AI agent that would actually sit in the decision-making system, and then it typically goes ahead. We actually see all the different blocks over here. We actually have the brake pedal, we actually have the steering control, we actually have the cognitive module here, gearbox, object detection, gesture, voice. It typically goes ahead and based on whatever it is the data that is captured, and then the efficient algorithm that actually takes it, makes the decision, how it will typically go ahead and act or perform the action to ensure safely taking the user to the destination and then making it much more comfortable with a lot of infotainment and entertainment functionality in the system. This all needs to happen because there could be hundreds and thousands of complex driving situations that could actually happen. So that brings in a very big impact over here. So that's typically the big influence of AI and machine learning in the automotive industry as such that actually brings in. So questions, comments? Quick time check. Are we on time? Need to cover.
Yes, sir. The schedule is still 1 o'clock. I think we can continue.
Perfect. Maybe I'd probably leave maybe some 5-10 minutes for questions at the end. So now speaking about, sorry. Okay, speaking about the AI and machine learning applications, I probably touch upon some use cases or some broader view. What are the different areas where this could actually be applied? Uh, I would not get into the details of what accuracy measures or how efficient the algorithms need to be used, because that's a different topic altogether in itself. So when we speak about the AI and machine learning, right? So currently, what we actually have is all of these particular AI and intelligence services are available on cloud. So we typically have AI optimized user-based inference, we actually have self-optimized route guidance, we have safety management, and then we actually have a lot of other functionalities that are already available in the cloud. So these are real-time services provided from cloud-based AI. And then we constantly have updates to the embedded services. Now, what this means is we actually have a backend AI system or use case provider available in the backend. And the challenge that actually comes in is how do we bring in these particular things for system specific and proprietary use cases, wherein which we actually have limited network effects. We consider car as a system, right? So that's where how do we bring these things and how do we bring them down into the embedded vehicle, bring down these artificial intelligence into the embedded vehicle, and how do we actually go ahead and have the closed loop scenario there, right? We capture the data from these particular analytics and then bring in new situations and new scenarios, and then go ahead and apply the A and ML techniques. So that's where I think that's typically one of the broader challenges that actually comes in. So what we already have is the algorithms are present, they are available, they are ready to use. Now the question is which algorithm to use, how efficiently we actually make that algorithm to use, what fine tuning we need to do for that particular algorithm. All depends on what scenario we're talking about, what's the user experience we are looking at. And if we consider the car as a case, right, there are lots and lots of scenarios. We keep safety in mind, different road networks in mind. We actually need to ensure these decision making are done in a timely manner, and then the right output is actually provided. So all of this last data, how do we go ahead, transmit, and then take meaningful decisions, keeping safety and security in mind, is of prime importance. So that's the area where a lot of research and analysis is actually going on in the AI and ML field. Now, we already know that this can run in the backend. It actually has the sufficient computing resources available and hardware exists, but bringing it down to the embedded device or the specific hardware or connected car or automated car solutions is typically the area where a lot of work is actually going on. So this is a quick cluster of what are the different areas or what are the potential applications of AI and ML. What we see on the right hand side is typically, this is again some 400 odd company statistics has been taken, which says in the existing business process, what are the areas where AI and ML have already been applied. Manufacturing and supply chain management is one area where the existing AI/ML approaches are applied. So the quality assurance, ensuring how do you maintain the quality of the car and the output. So that's another area. And then the in-vehicle experience is another area where already existing business processes are there, and then more evolution is actually going to happen in this area. So now when we look at the new AI-enabled products and services, right, what is being looked upon is how do we integrate traffic and infrastructure, how do we inspect that, fleet management, having lots and lots of heavy loaded vehicles, transportation from one place to another, how do we manage the fleet services. There is another area where we can use a lot of AI machine learning algorithms. Predictive maintenance, I mean, like with the vehicle getting so complex, lots of hardware, lots of chips, lots of sensors, actuators, the maintenance of the vehicle and being able to predict it becomes a very, very big use case that actually comes in. And then autonomous driving that we already spoke about already, how much of AI would actually influence. Now, connecting this back to our trends that we actually spoke on. So when we see the manufacturing and supply management, so this typically comes into the automated and electrified section primarily. It could differ from the other areas also, but I have actually highlighted only the primary areas. Automated because we want to make a lot of manufacturing and supply chain management automated, and robots, for example, we actually have robots which could actually fit into different parts, and the production plants have the robots ensuring the parts are supplied and then defective pieces are identified. Electrified purely because we want to actually ensure right channel stations are available, the battery management is actually done. We actually check the different devices for compatibility on the emission and then the battery usage scenario. So that's where the manufacturing plant needs to take care of the electrification part, and then also to a certain extent supply chain management. So the next one is quality assurance. So this is mainly how we could actually automate the complete quality control when the vehicle is actually deployed, right? How do we automate the entire process to check the quality of it? In vehicle experience, mainly automated connected also come here, but primarily personalization actually comes into picture because within the vehicle, how user actually becomes a critical part, how the vehicle experience for each of the user is personalized and then utilized. So the next one in the autonomous driving scenario, we would actually speak about touch upon the shared mobility, right? We could actually have a driverless car. We could just go in, go to that particular car, go from the source to destination, have all of the particular specific customizations available, and then they typically use that particular part. So certain extent personalized also comes into picture here, but it more goes into having a good in-vehicle experience inside an autonomous driving vehicle. So the next three categories, the traffic infection, fleet management, predictive diagnostics, all of these actually come in the connected segment because they need to connect to infrastructure and then store a lot of information in the cloud, operate with cloud, connected tasks come to picture, and then a lot of these processes need to be automated, considering a driverless and a self-driving car. So automated and connected come into picture over here. Think about each of the use cases. I know, sorry for a lot of text in this, but I've tried to replicate most of the categories here in this slide. What we have the space and personalized, and some examples of what would be the possible use cases. I'll probably touch upon the quality control. Now, in the quality control, we could probably have sensor-based AI and object recognition. Now, this will identify and remove what are the defective pieces. Today, we actually have the system going for production, and in the production unit, we need to assemble a lot of devices, hardware, software components. It needs to match the different variants. For example, if the car is targeted for India region or Europe region or North America region, then it needs to have certain set of chipsets and certain functionality available. Now, how do we ensure all of these things are taken care of? If we actually have object recognition, what kind of object is being considered in the production unit? It will actually have sensor-based artificial intelligence and then identify defective pieces and then remove that or stop production at that particular part. Other scenarios that I just briefed upon in the previous slide, we actually have robots that we used in the production infrastructure, which actually go ahead and check these particular parts. Let's remain on the quality control, maybe pretty high level use cases that we are speaking about there. And will be like the next one is mainly on the predictive maintenance. Uh, this typically is termed as reactive maintenance. Yes, the term is a little skeptical because when we say predictive and then we say reactive maintenance, right? The term reactive comes in the picture of we react based on the AI and ML algorithms and then the decisions that it actually takes. So we need to measure the health of the equipment, whether a particular part needs to be repaired or replaced. We typically identify the health of it and then notify the user well in advance before it either breaks down or the problem arises. I'm sure most of us would have faced this challenge, right? We have given our car for servicing, and then there will be certain parts that are actually gone, and the dealer or the car service center says this part is not available now, and then the vehicle comes back without that particular part being replaced. So, determining the health and then figuring out which dealer or which particular center has these parts, or even going to the next extent, we determine that this part is actually failed. We connect to the dealer and then request him for the part to be available, and then notify the user once the part is available to go ahead and get this particular thing replaced. That's a totally different user experience altogether that we actually bring by bringing in a lot of machine learning algorithms in this. So the next one is supply chain optimization. So we can typically figure out what would be the prices, whether the prices are actually fluctuating, maybe increase or decrease based on what exactly is the part needs that we need. And then overall, the final price could actually be an optimal price for the user, which it keeps storing the information about price fluctuation and then constantly learns on what type of components or habits they are actually their prices being fluctuated, and then gives the best possible price to the user. So more on one of the optimizations in supply chain. With predictive diagnostics and maintenance, we actually check the health of the vehicle. We constantly have diagnostics routine in the vehicle, which keep telling the user if there is any faulty component, and even it would recommend which is the preferred dealer. We can even go to an extent of immediately giving users some instructions with a set of previously learned mechanisms. Say if a problem A exists, or if the AC is actually down, right? AC is not working. One simple thing would be check the water level and then whether there is some kind of a blockage in the water being coming in. So these things user can solve himself rather than going to the dealer. So these kind of information could also be provided to the user, and that requires a lot of machine learning in it. Safety, tracking the driver behavior, when the driver drives rash, drunken driving, when the driver drives in the night and then has drowsiness, all of these particular information to be captured. Whether the driver does frequent lane change, that would mean like it would consume a lot of battery in an electric car. Whether the driver frequently changes the AC temperatures, maybe increases or decreases based on what kind of audience or people are there in the car. All of these things would actually be captured, which would again go ahead and help us in efficient utilization of the batteries within the vehicle, and also bringing in safety with respect to type of driving from the driver. And then we can also have in-vehicle sensing if there are any objects in the car or maybe if we use some kind of a peg in the car aside, right, then it would actually sense within the vehicle and then notify the user. These are some of the safety mechanisms. I think personalizations we already touched upon, connecting smartphone to the device and then transferring all our personalizations. And we could also go ahead have insurance premium discounts. These are some examples I have to take. There could also be lots and lots of marketing that could be done based on the user specific interests. So system keeps storing it, and then it goes ahead and does a lot of marketing with respect to product, additional parts or new features, add-ons, updates, and all of these things could actually come upon. So these are some of maybe very high level idea about the potential use cases. Now there are a lot of other areas where lots and lots of research are actually going on. One is actually termed as capacity as a service. Now, when we say capacity as a service, is the road capacity. Now, how much vehicles can actually travel on this particular road? Now, consider a fully automated system somewhere in 2025 or 2040. We can go ahead and predict, okay, this particular road capacity is so many vehicles. If there are more number of vehicles that would enter into it, you notify the user that it has reached the road capacity. You actually go ahead and uh, take an alternate route. So the next one is congestion, wherein which you actually have the distance and electrification based pricing. Now there is a traffic congestion that actually happens, and in that particular traffic congestion or even the road congestion, whether you can actually go ahead and whether your battery will survive traveling the distance. So in that way, we can recommend in this traffic congestion, based on the past learning, you could drive maybe 10 miles with the amount of battery that is actually left. So a lot of analysis going in this particular direction. The next one is another very interesting part, which is more of a land use. I think most of us would know, right at the center of the city, maybe parking in India road is very costly. So with automated driving and then faster speed and then reaching out to different areas faster, we could really leverage parking at suburbs. And whenever we are going to take the return trip, right, maybe 10 minutes before that, we notify or connect with the car, communicate with the car. So much time I'll probably be reaching this place. Please come and pick me up. So it is literally like a car being treated as a user and we communicating with the car. So that also reduces the parking cost for each of the individuals. So some areas and discussions in this particular direction that actually happen. Okay, so this is probably the last slide that I actually have with respect to the challenges. So the first and foremost challenge, this is more than the data that we actually have. How do we go ahead and teach the car what are the rules of the road, and then how do we ensure they actually follow and navigate to their own destination? Each of the country, each of the locality has their own rules. Each of them have their own traffic conditions. Each of them have their own challenges. How do we teach the car when you speak about the self-driving cars? This is a big challenge that actually comes in. Lots of simulation environments coming in, figuring out what kind of a route we want to have, running the vehicle in those simulated routes, capturing that particular algorithm, and how do we bring in the real-time aspects into it? How do we go ahead and capture the billions of hours of data? Simple point when we speak about completely self-driving car, how can we make the car predict that there is going to be a potential car accident that is going to happen? How do we bring in learning in that area? So what kind of data do we actually collect? And it's going to be really expensive with such large data being collected. So few technical challenges actually come, maybe taking the compute and act scenarios in the pipeline. The cameras, the sensors, how do we ensure that they are accurate and then provide real-time information so that the user needs to react within the prescribed time so that they don't really go ahead and sneak it on the car, right? And how do we process large data and then keeping the complex and dynamic driving environment? So one of the areas that is being largely worked upon, and some analysis and technological developments happen in this area, is the really efficient radar data and the camera systems that are actually coming. So this way we would actually ensure safety with respect to physical timelines. This is one challenge. In reality, how this would actually shape it. Data privacy we already discussed. I think we are going in towards centralized ECUs. How we actually go ahead and store the common functionalities, which system goes in, how do we ensure regular upgrades actually happen? Do we want to make yearly upgrades, half-yearly upgrades? Problems are actually seen, lots of software content and complexity coming into the system. How frequent do we update, and what's the impact of the cost to the end user? Some of the technical challenges that actually come. And the other ones are more on the infrastructure challenges. How do we ensure we actually have the right charging station? So we want to drive a simple scooter now comes in with it can actually drive up to 40 kilometers, 60 kilometers based on the battery charge need. Now, how do we check what's the current battery need and where is the nearest charging station? Whether the city provides the infrastructure with the charging stations, and the cost affordability for the electric vehicles. How a different segment of people afford these particular costs. But especially in tier 2 and tier 3 cities, the infrastructure is something that is still evolving. These are some of the challenges that I could actually list down and put it forward. Yeah, now keeping the floor open for any questions or comments. Hello. Hello. I'm audible? Still fine.
Yes, sir. Yes, sir. You're audible. So, participants, any questions? Okay. Okay. I think, yeah, they don't have any questions.
Okay. Then just a quick feedback. I mean, like, just from the participants. I mean, like, in line with your team, or I mean, like, some other areas. How did it fit from your expectation perspective?
Yes, sir. We will be collecting a formal feedback from all the participants, and we will be sharing the feedback with you, sir. We have a procedure of collecting the feedback, and we will share the feedback with you.
Okay.
Yeah. Okay. Yeah, I think. Yeah. Will any participants have any questions or any feedback to share? You're open to share that. So I think that's it as of now, sir. So we will share the feedback with you, sir.
Yeah. And thanks a lot for this already. And then, like,
The only thing is, sir, we had some problem with the audio. I mean, the only thing that we faced was that, but otherwise, we really enjoyed the content and it was very informative. I mean, we do hear a lot about AI ML and how it is impacting everything, and we really got to know through the pathway that you showed us. It's showing the current trends and the history, everything. We got a clear picture of that. Thank you for the content.
Sure. Thank you.
Thank you, sir.
Yeah.
So, okay. So, thank you, participants. So, I think we'll break for lunch now, and we will get back at 2 o'clock exactly with the next session. Thank you all, and thank you, Sunil.
Thank you. Bye.